Okay. Now we already know that we are going to have say our railway track is going to consist of. We are in today's class we will be studying regarding the track stresses. As we know that the railway track is consist. It is a composite structure which is having the rails, sleepers, then fastenings, ballast, right, and finally the subgrade. Right. Now, the load distribution will happen right from the rails, right? It is the load distribution is going to happen right from the rails, right? Right from the rails to the sleeper, and from the sleepers, right? It is going to be transmitted to the ballast, and from the ballast, right? It is going to be transmitted to the subgrade. While uh, while the track or a superstructure which is laid upon a subgrade, the subgrade serves to bear and distribute the imposed load, and it is the uniformly distributes it to the ground level. Whatever the load is going to come from the right from rails to the your ballast, right? What your subgrade does is it is going to distribute the load directly to the soil, and it should be an evenly distributed. The it is going to distribute the load evenly, right, so that there will not be any kind of say immediate failure which is going to occur in case of your ground surface, right. Subgrade serves to bear and distribute the imposed load with the diminished unit pressures and provide the smooth platform on the superstructure that can be laid. Okay, now we will see what kind of track stresses are that are going to be developed on your say railway track. Okay, now the different kind of track stresses that is going to be developed on the railway track is we are going to have the stresses due to the wheel load, right, and due to the hammer blows, right. What are those hammer blows we will be seeing, right, and then the horizontal thrust, then pressure exerted by the flanges of the wheel, right, and the stresses due to the irregularities in the track. So these are the different kinds of stresses that is going to be developed on your railway track. Now, as we know that the wheel load, right, the wheel of your train is itself is a heavy. So here the static load due to the wheel is going to be transmitted to the point of contact to of the rail, right. What is happening here is, right, the wheel load, right, the wheel load is going to be directly, it is going to be submitted to the your directly it is going to be submitted to the wheel your rail of your permanent way. Okay, just a minute, we will see how the load is going to be distributed. Okay, now what is happening is here in above this particular rail, your wheel is going to come, right. The wheel, the train wheel is going to come on this, right. This train wheel is going to have the static load, right. It is going to have the self weight. So self weight of the load is going to be taken by the rails, and from the rails it is going to be transmitted to the sleepers, and from sleepers it is going to be transmitted to the ballast, right. So when the rail is in the static position, that means it is not moving, right. When it is going to be the static at one particular place, right, it is going to have an it is going to transmit its load to the rail, right. So the rail will be under the stress due to the static effect of the wheels, due to the when it is the train is in the stagnant portion, or when it is standing, right, the wheel of those train is going to have some load, right. So that load is going to be transmitted to the rails, and due to this the rail will be having the pointed loads, right. So point load is going to act the point load is going to be act on this particular railway track. So the railway track will be under the, or the rails will be under the stress, right. Now first in the wheel load we are going to have the two types, right. In wheel load, right, we are going to have the two types. One is the static load and one is dynamic load. Okay, one is static load and one is dynamic load. Now we will see, right, how the dynamic load uh, how the dynamic load is going to affect the rail, right? Moving train. See, this is how your wheel load, this is how the wheel load is. When it is in the static position, it is going to create an impact. When it is a dynamic load, dynamic state, that is in the moving state, also it is going to create an impact on the rails, right? The dynamic effect is goes, it is going to be caused due to the momentum of the due to the speed and the hammer blows caused by the moving wheels. See, this rail, right, this wheel is going to be moved continuously. So here what is happening is the load will be continuously, it is going to come on your rails. The load is going to be continuously, it is going to be come on the rail, and it is a dynamic in nature because it is continuously moving, right? If the load is going to come, right, the dynamic effect is caused due to the speed and the hammer blows of the moving wheels, right? Under the ideal condition, no change in stress should occur with the speed, right? Under the dynamic condition, what is happening, the only the point load is going to act over these particular your rails. But when it is in the dynamic portion, or when it is in a dynamic condition, the load will be continuously, it is going to come on the rail and not in a single position. It is continuously, it is going to come where your train is going to move. The change or increase in the stresses occurs due to the ineffectiveness of the track and effect of the friction. Again and again, there will be the some of the friction is going to occur due to this particular thing. Right. The speed or the impact factor is measured with the effect of speed, vibrations of the rail, and the moving load. Right. Not only these kind of stresses or the your same dynamic stress is going to act. Again, the vibration that has been created due to the momentum of your wheel on these particular rail, as well as the friction, is also going to cause some of the stress on some stress on your rails. So this is how your dynamic load is going to create an problem. Now we will see how the hammer blow is going to have an effect. Now, the third is we are going to have, right, the hammer blow, right? This is what the third effect. We are going to have the hammer blow, which is going to be caused on the your rail wheels, right? The hammer blows. Now, we will see what is this particular hammer blow is. Right now, here you can see that there are some of the crank rods are there, right? This is the crank rod, right? It is the reversing crank rod. There are some of the rods are there in your railway wheels, right? Now, due to it is observed that due to the revolving masses, right? These will be in the under the motion when the train will be under moving condition. These crank bars, right, will be under the motions, right? It is not static. It will be under the motion. It is observed that the revolving masses like crank pins, rods, right? These are the rod, crank pins, right? The revolve eccentrically with the wheel. These are going to revolve eccentrically with the wheel. A part of these loads, right? This is connected with your wheels or the crank bars. This is going to be connected with the wheels. Now, a part of these loads is going to be counterweight provided on the either side of the eccentric revolving masses. Now, the load again, this will be again moving up and down, up and down. So when it is going to move, right, it is going to create some of the hammer blows on your the rails. So your rails, the horizontal component of the your bars and the vertical components, it is going to be remain unbalanced, right? The horizontal, when it is moving under the, this will be moving under the horizontal movement, and this is going to have the vertical movements. So when it is moving in such a way, right, the forces is going to be an unbalanced force which is going to act on the rails. So again, it is going to create the hammer blows. Now these hammer blows are seen when counterweights are vertically down and upward, it is going to be lifted. So hammer, it is continuously due to these crank bars, right, there is going to, some of the hammer blows is going to occur on your rails. So it is moving up and down, and then this is moving to the horizontal. So what is going to happen? Ultimately, there is the hammer, it is hammering effect which is going to occur on your rails. So it is having some of the hammering effect will be observed on your rails. Okay, so this is how it is going to affect your the hammer blows. Now we will see what is the horizontal pressure or the horizontal thrust, right? The steam pressure, right, the steam pressure which is going to occur on the piston of a steam engine, it is going to be transmitted to the wheel crank and through the connecting rod. Now what is happening is here, right, we will see. Right. Now here we are going to have some of the piston, right? Here we are in the case of your steam engine, right? The steam pressure is going to be transmitted to the wheel crank, right? This is your, it is going to be transmitted to the wheel crank through your connecting rods. Now the connecting rod is at an angle with the piston rod when the either crank pin is move up or down and the center of the wheel, right? The vertical component of the piston, right? The vertical component of the piston, right, it is force, it is going to add on the wheel when the crank pin is a downward direction. Now the wherever the crank pin, right, it is in the downward direction, it is going to create an the pressure. The vertical component of the piston, right, force adds to the wheel load when crank pin is in the downward direction. Okay, the hammer blow due to the steam does not take place in case of your electric locomotives. Now this hammer, your horizontal thrust or the hammer blows, it is not going to occur in case of your electric locomotive, right? The maximum effect of the hammer blows due to the steam does not have the synchronize with the hammer of the this. Then we will be having the one more effect, right? The pressure exerted by the flanges on the sides of the rail. Now as I have already told, when we will be having, right, the when we are going to have the motion of your most moment due to the momentum of the wheels, there is a the pressure is going to be created on the flanges, right? The pressure is going to be created on the flanges because there is a direct contact between the wheel and the rail. So the flanges will be under the pressure when it is going to be in contact with the your rail wheel, your train wheel as well as your rails. So direct pressure is going to be created on the flanges. Right now, top and bottom portion we call it as a flange, and the middle portion we call it as an the web of the rails. I think you already know about it, so I have explained also in your previous classes regarding this. Now, the stresses due to the irregularities of the track. So this is also one of the effect which is going to be caused due to the irregularities of the track, which is going to occur when the train will be under the moving condition. Right now, what kind of an irregularities will occur due to the certain of the reason when the ballast or the subgrade, right? These are the reasons why the stresses due to the irregularities of track is going to occur. Right now, when a ballast, right, when a ballast or subgrade or both are not evenly or smoothly laid, right, when we are going to have the irregularities, right, when the ballast is not going to be filled properly, right, in order to support the sleeper, there will be an irregularity is going to created or undulation is going to be get created on the railway track. Right now, when we when see if we take the track, right, if the ballast is not filled properly below the sleepers, right, if the ballast is not going to be properly filled below the sleeper, now what is going to happen is when the moving load is going to occur, what will happen? There will be a depression is going to be created in these particular the railway track. So what is going to happen? It is going to create the some of the undulations, right? It is going to create some the depression on the rails, right? As a result, it is going to create a non-uniform and unsmooth ride when we are going to deal with such kind of an the when if it is the ballast is not going to be filled properly, we will be ballast or subgrade is not filled properly, such kind of an stresses are going to be get developed. Then the non-uniformity in the gauge, right, and result in oscillations, hammer blows, and the side lateral thrust on the rails. When the gauge distance, right, when the gauge distance between the rail is not going to be proper, then also it is going to create the more amount of the hammer blows, and there will be the more amount of friction is going to occur in between your rail wheel and your train wheel and the rails, right? So it is also one of the thing which is going to occur when the due to the irregularities of the track. Now when one your the when we consider this track, when the one level is at a higher level and one is at the lower level, one rail is at a lower level, then also it is going to create some of the stresses, right, due to the irregularities of the track. Now we will see the additional stresses that it is going to be get developed on the curve. Now when the curve is there, there will be the additional stress is going to be created on the rail. Now what kind of additional stress we will see, right? In addition to the stresses, right, normal stresses, right, which are not seen on a straight track but occur on the curved track. Normally when the track is curved, there will be the more amount of stresses is going to be occurred on the curved track. So we will see what kind of stresses that it is going to occur in case of your the curved track. Now the lateral binding due to the real due to the rigid wheelbase of the vehicle, that lateral bending, right, whenever we are going to take a turn, right, so there is a lateral bending is going to occur on the curvature side. So it is also one of the reason why it is going to create an it is going to create the stresses. Now non-uniform distribution of the pressure over the outer and the inner rail. Now if whenever in the curvature is there, if the no load proper load distribution is going to occur in case of curve, then again it is going to create the some of the problem. Now this is what the problem, the stresses which are going to be created on the track, right? Now we will see what kind of a stresses that it is going to be created on your the stresses in case of your sleeper. Now we will see what kind of a stresses it is going to be created on a sleeper. Now it is the sleeper is going to have, right, the sleepers are subjected to the permanent stresses arising from the fastening due to the longitudinal forces in the rail, and it is going to create the stresses on the rail. Now again stresses in the sleeper, we are going to have the wheel load, right? First one, we are having the wheel load, right? The greater the wheel load, the higher will be the stress on your sleeper, because the wheel your from the wheel the load is going to be transferred to the rail, and from the rails it is going to be transmitted to the sleeper. So wherever we are going to have the greater load, right, wherever we are going to have the greater load of the wheel, right, there we are going to have the greater stresses on your greater stresses will be getting created on your sleepers also. Now, weight transfer from the wheel to wheel on the same and different axles, right? We have shown, I have shown you the your crank pins and all, right? Now, weight is going to be transmitted to those crank, and from again those cranks, again some of the load is going to be transmitted to the your rails, and from the rails to the sleeper. Now, higher the speed, right? Again, there is due to the speed also there is the track stresses is going to be get created on these sleepers. Again, the whatever the things, right, whatever in the while telling you the track stresses I have told, right, when the wheels are going to move, the your rails will be under the continuous dynamic load is going to act, and due to the friction between the rail and your the sleeper, due to the friction between the rails and the friction between the rail wheel, right, wheels, right, there is an the pressure is going to be created on your the track, and again it is having a dynamic load, right? Due to that dynamic load, again the dynamic load is going to be get created due to the higher speed, right? Next is the elasticity of the rail. Next is due to the better shock and vibration absorbing property, load taken by the sleepers will be the less, right? Due to the better shock and vibration absorbing property, the load taken will be by the sleepers will be normally the less. Now, efficiency of the fastening. If the if your fastenings are have been in between the two rails, the connection between the two rails, if it is not proper, right, then again it is going to create the more stress, on your rails, right? So next is again your the sleeper should have the better strength in order to have bear the stresses, and your maintenance of the track should be proper, and the stiffness of the rail should be proper in order to have the better strength, better the load taking capabilities, right? If you want to have, then the sleeper should be quality should be maintained if we want to have the smooth riding. Now there are some stresses will also be created on the ballast also, because ultimately the load has to be transmitted to the ballast. Now we will see how the rail the stress on the ballast is going to occur, right? We will see how the stress on ballast is going to occur. See, the now the from the sleeper, the load is going to be transmitted to the your ballast. Right here, the transmit of the pressure from the sleeper to the ballast depend upon the elastic properties of the sleeper. Now, elastic property is after the moving of the say rail or the train, right? If the sleepers are capable to occupy its original position, then the load transmitted to the ballast, it is going to be a little bit less. But if the sleepers are of not of a good quality, and the maintenance of the sleeper has not been done, then again the more amount of stress is going to come on your ballast. Right now, the transmission of the sleepers from the load is going to transfer from the ballast to the your sleepers to the ballast, and it is completely depend upon the elastic properties of the sleeper. Now, the degree of compaction and the nature of the ballast bed, right, it is dependent on that. Now, how you have filled your ballast, right, in case of your filling of your permanent way, right, if the ballast is not filled properly, then again if there is a gap in between, there is too much amount of pores is going to be get developed, then entire track is going to be get distributed. So this is how your load this is how your load is going to be get distributed to the ballast from the sleepers to your the ballast. Okay, and this is the figure shows the typical distribution of pressure from the sleepers to the ballast and the formation. So this is how your stresses is going to be get created on your say from the rails to the sleeper, from the sleepers to the ballast. So this is how the load get distributed. So in order to have the proper stress management of the wheel, right, whatever the track maintenance what we do in case of your permanent way, it has to be done properly, so that the load that has to be distributed from the rails to the sleeper, from the sleeper to the ballast, it should be and from ballast to the subgrade should be evenly distributed. If we don't maintain the proper track maintenance, right, if we don't have the track maintenance, then the load will be unevenly distributed, and again there will be say there will be the disturbance in the track, and ultimately it is going to the impact the smooth impact the ride of the train. Okay, sometimes it may lead to the failure, and from the failure it is a failure of the permanent way, and the failure of the permanent way will lead to the derailment, which is going to create an accident. So whenever we are going to maintain, the track maintenance is going to be very, very important aspect when we consider the permanent way. See, now we will see the one more topic. We will see the today we will cover one more topic, that is your widening of gauge. Right, we will cover one more topic, that is the widening of gauge. We will see in today's class. Now, as we see, right, when vehicle normally assumes in a central position, now vehicle will normally in a central position when it is going to be moved on a straight track. Right, if we consider the track, right, if we consider the train, right, it will be normally in a central position when it is in moving on a your straight track, right? When it is going to be in a straight track, see this is your if it is in a straight say track, right? If no curves are there, normally it will be moved on a say center of your track. Now the problem comes, right? Now we need to have the widening of gauge on the curves. The reason is, right, the reason is the situation, however, changes on a curved track, right? A vehicle normally assumes the central position on a straight track and the flanges of the wheels stay clear of the rails when in a straight position. Now, when we are going to have the curved tracks, right? We are going to have the curved track, the flange of the outside of the wheel leading to the axle continuously, it is going to rub against the rail. Now, what is happening over here is, just a minute. Yes. Now, what is happening over here when it is in a curved condition, right? Now, your inner wheel, right, will be taking a less distance. It is going to have a less distance, but your outside wheel, it is going to have it has to travel the longer distance when it is the curve is there, right? The inner wheel, right? The inner wheel, it is going to travel the shorter distance, and the outer rail, the outer rail, it has to cover a larger distance, right? As a result, what will happen is, right, this outer rail, it try to move out, right? The outer rail, in case of your curve, it will try to move out. So there is a bit necessity to have the widening of the gauge when we are going to move on a curved track. The inner wheel will travel a smaller distance, whereas the outer your wheel will try to have, we will have a larger distance, right? As a result of this, what will happen to this is the outer wheel will try to move outside. Now, as a result, what will happen? There will be, if we don't maintain the widening of gauge, right? What will happen is, right, there will be the friction is going to be get created between the wheel and the rail. Between the wheel and the rail, there will be the friction is going to be get created, right? So due to this, right, if we don't have the widening of gauge, there will be the continuous rubbing of your rail wheel, and the your train wheel and the rail is going to occur. And again, the frequent maintenance is going to be required in case of your the curvature of the rail. So when we are going to take the curvature, right, when we are going to have the wherever the curvature is there is a necessity to widen the gauge distance between the two rails. So this is what the widening of the gauge is, right? Due to the coning of wheels, the outside wheel have a longer distance compared to the inner wheel. Now, this what will it will do is, right, the wheelbase causes the trailing axle to occupy the different position. Due to the change in the radius, what will happen? There is a different same position is going to be created on the rails. In effort to make up for the difference in the distance traveled by the outer wheel and the inner wheel, the inside wheel slip backward and the outside wheel will skid forward. That is what it will try to move outside, right? This is why there is a reason why we needed to have the widening of gauge near to the curve, right? Now, the extra width on the curve that has to be provided, the formula that we are going to use is 13 into B plus L whole square divided by R. Now, what is B? B is nothing but the wheelbase, right? R is nothing but the radius of curvature. L is the lap of the flange in meters. Okay. Now, H. Now, this is how we are going to provide the increase in the gauge when we need it to, we are moving on the curves. For a curves, for a radius more than 350 meter, right? We should have the widening of gauge up to plus 10 that is 1 centimeter we should move the outer rail outside, right? Then if it is a broad gauge or narrow gauge, we should have 10 Now for our curves with the radius more than 100 meter, for narrow gauge we should have around 15 we should take the outer rail outside. So this is nothing but the widening of the gauge on the curves. So this is this becomes very important when we will be having when the train will be moving on the curves. So I hope the things are understood. In the next class, we will be discussing regarding the geometric design of the track. So here again, there is a curve is going to come, super elevation is going to come in the next class, and it is going to be very important as far as your examination are concerned. Okay, the things are understood. Yes,
Yes,
track
sir.
stress, track stresses, clear? Komal, is it clear?
Yes, sir.
Padmashri?
Yes, sir.
Okay. So I think we will end the session over here. The next class we will be studying regarding the geometric design of the track. Okay, so we will end up the session over here. If any doubts are there, please let me know. Any doubts are there? Yes, any doubts?
No, sir.
No, sir.
Vishwa Alur, any doubts?
No, sir.
Okay, we will end up the session over here. Thank you.